in addition to understanding where the data is concentrated, we also need to understand how spread out or dispersed the data is. The range of a data set is the difference between the largest and smallest values. Range is very sensitive to extreme values. It does not take every value into account, and therefore does not truly reflect the variation among all the data values. Range is mostly known for the range rule of thumb. This is a crude but simple tool for understanding and interpreting standard deviation. We will discover that for normal behavior, 95% of sample values lie within 2 standard deviations of the mean. Any value in the upper or lower 2.5% tail is deemed statistically significant. For this reason, we use the range divided by 4 as a rough estimate for a more useful and complex measure of dispersion called standard deviation. Variance is a more complex and useful measure of dispersion. It is equal to the sum of the squared deviations from the mean divided by the sample size. Sigma squared is used for population variance, and S squared is used for sample variance. Note that these two formulas are slightly different. For sample variance, we divide by sample size minus 1 instead of the sample size. Sample sizes tend to be far less than population sizes. If we were to divide by n, sample variance would be underestimated compared to the value of the population variance. Dividing by n minus 1 adjusts our estimate in a more robust manner. Standard deviation is the square root of the variance. It is a very common measurement of dispersion in statistical circles. Variance and standard deviation are both measures of spread, but they each have their own uses. While standard deviation is a more commonly reported measure, it is not an unbiased estimator. Variance, however, is unbiased and will be the centerpiece of many of the statistical tests we will see later. Both variance and standard deviation are best calculated with technology. The coefficient of variation equals the standard deviation divided by the mean and is expressed as a percentage. It is a measure of standard deviation relative to the mean. Coefficient of variation is of particular use in gauge R&R studies as a measure of quality assurance.